Salam Sejahtera. We are from Group 6 and we will be presenting PCM, which is pulse code modulation. My name is Sharvin and I will start with introductions. Okay, PCM or pulse code modulation is a method used to digitally represent analog signals such as voice or other continuous signals. It involves the sampling of the analog signal at regular intervals and then quantizing each sample into its digital code. So we have three things to talk about. The first is sampling, the second is quantization, and the third is encoding and decoding. Sampling, when PCM begins with the process of sampling, which involves discretizing a continuous analog signal by capturing its amplitude values at regular intervals. By sampling the analog signal, PCM creates a series of discrete data points, converting the continuous waveform into a sequence of discrete amplitude values that can be represented digitally. Next is quantization. After sampling, the continuous amplitude values are quantized by mapping them to a finite set of discrete levels. Quantization in PCM involves assigning digital codes to each sampled amplitude, determining the resolution of the digital representation. So there are two types of quantization, linear and nonlinear. For linear quantization, it involves equally spaced quantization levels. The amplitude range is divided into uniform steps, simplifying the quantization process. However, it may not efficiently represent signals with varying levels of detail. For nonlinear quantization or companding, adjust the spacing of quantization levels to better match the characteristics of the signal or human perception. Companding can allocate more levels to regions where signal details are critical and fewer levels to less critical regions. Then we have encoding and decoding. Once quantized, PCM proceeds with encoding and decoding. When encoding, the quantized samples are encoded into binary code. Each quantized value is represented by a binary sequence. Then, when decoding, the binary code is decoded to reconstruct the original quantized samples. Decoding is essential for the accurate representation of the original analog signal.
Hi, my name is Nuraya Adriana Batrisha binti Razali. I will present to you example 1 coding MATLAB. This is coding for example 1. The figure 1 shown as plot A is referred to analog signal. The X label and Y label is time and amplitude. The next one is plot S. S will refer to sample signal. N is equal to 3 bits. Y equal to U encode and R equal to U decode. Y U encode, the S will store in Y. Meanwhile, Y will store in R. So the next line, figure 2. Figure 2, the plot Y will refer to encoded signal. The S and Y label is same, it's still the same, time and amplitude. The next output, plot R, will refer to decoded signal. And the next line is figure 3. It will plot P. P is equal to square signal. S and Y label is still the same. This code we demonstrate the process of encoding and decoding a signal using uniform quantization. The output will be shown like this. This is figure 2, which is square signal. And this is figure 2, encoded and decoded signal. And this is analog and sample signal. The analog and sample signal is same, the amplitude is same. While the encoded and decoded signal, the amplitude for the below and the amplitude for the negative side is more higher than the upper one. And the square signal, this is the output for the square signal. So this is all the output for signal.
This is an example MATLAB for example 2. First of all, this coding has two figures, that is figure 1 and figure 2. The difference between the figure 1 and figure 2, the figure 1 has the received signal using compounding, while the figure 2 receives signal without compounding. Let's see the difference between these two outputs. Both of these are same, but the ones make them different between figure 1 and figure 2, that one of them using compounding. Remember that. You can see here the figure here, the result for the figure 1 receive signal using compounding, and figure 2 receive signal without compounding. So for the next step, we will be creating these both of the output by using Simulink. Instead of we will be using coding MATLAB, we will be using Simulink by using a block. Here, let me show you. I already make it early. Here's the example tool for the output that will be produced like in the MATLAB. Okay, so before we doing anything, we'll be provide our component first, such as the first thing we need the sine wave, the clock, so we can check the time, and the divide. Okay, for the figure 2, that it without signal without compounding it will be need uniform encoder, uniform decoder, and scope. While the figure 1, for the compounding signal, we need Moore compressor, uniform encoder, uniform decoder, and Moore expander. Last but not least, the scope. This scope actually is the output for will be received. Okay, let's run first. And then first of all, we check the figure 1 with compounding signal. As you can see, this is the same as the signal that we got from the figure 1 that using compounding. And for the figure 2, we get this kind of signal that also same with the figure 2 that we using at the MATLAB. That's all for me. Thank you.
Hi, my name is Nur Shazira binti Mama Asaad. Today I will show you task number 3, which is the question asks us to use the MATLAB Simulink for the question 1 and question 2. So this is the Simulink diagram for question 1 using signal generator. Then we set the amplitude 1 and frequency 1, and the unit is set in Hertz. Then we use pulse generator. We change the period into 1/10 and pass width to 50. Then we use dot product, uniform encoder, we set bit 23, and uniform decoder, we set bit 232. Next, we put scope for analog and sample signal. Then we put scope that connect from pulse generator. Last one, we put scope connect to uniform decoder. We run the Simulink, then we get this output signal for encoded and decoded signal. Next, we get the output of analog and sample signal. The last one is the output of square signal. So this all the output for Simulink for question 1. That's all from me. Thank you.
Assalamualaikum. My name is Nur Hidayati binti Muhammad Sauti. Today I want to explain the Simulink for question 2. For question 2, we have two types of compounding. First, without compounding. Second, with compounding. In without compounding, I have used signal generator, uniform encoder, uniform decoder, and scope. But for with compounding, I add Moore compressor and Moore expander. This is for 2 kHz for 8-bit result. At the right with compounding and the left without compounding. This is 2K for 6-bit result. At the right with compounding and the left without compounding. For 8-bit doesn't have different, and for 6-bit also doesn't have different. Thank you.
So for conclusion, PCM is widely used in various applications, including digital audio and telecommunications, due to its efficiency in representing and transmitting analog signals in digital systems. The choice between linear and non-linear quantization depends on the application's requirements and the characteristics of the signals being processed. This comprehensive process ensures the accurate representation and transmission of information, allowing for efficient storage, transmission, and processing of analog signals in digital communication systems. Thank you.